right, so our goal is to sort a list. Of course, there's a lot of ways to do this. And in particular, you're probably just going to use an existing function most of the time. But let's see what's going on under the hood when we do this. And let's save it all. And let's go up to terminal. npm run dev. Ooh, looks promising. Open the console window. Well, that's good. And sure enough, these were put into the right order, as you'd expect. But the question is, how do we do this ourselves? What if sort didn't exist, or more realistically, you just wanted to know what was going on under the hood? So today I'm going to show the secret ingredient sort. This is the simplest sorting algorithm I know of, aside from just letting someone else do it for you. So let's discuss some requirements for this. We're going to take in some sort of input, which is going to be a list, an array. And let's make it an array of numbers, just to make things simple for this example. There's no significant change, but it's just a little bit easier this way. And the format, there's different ways to do the input and output, but let's just say we're going to change this in place. And similar to this sort algorithm, we're going to modify what's there, and we're going to return a copy of the list. It's sometimes just easier. Now let's get some requirements here. Okay, again, some of these decisions, they're not that exciting. I'm just picking the simplest thing. You could always make a copy of the array if you didn't want to change it in place. And finally, what exactly are we doing here? We're sorting, of course, but let's be a little bit precise what I mean by sorting. The output should be a permutation of the input, and each item in the output should come in order. So let's go ahead and type this out. Like I said, the output will be a permutation of the input. That means we're just rearranging things. We're not adding things or deleting things. The size will be the same. And then we want to say that each item comes before the next item in the list. So So let's just say that the nth item of the list will always be less than the following item. And then this last one's going to sound a little bit silly at first, but when we get to it, it'll make more sense. It won't run forever. It will give us an answer. Seems like a good place to start. All right, so how do we actually do it? Well, I'm going to defer this a little bit. And then I want to verify this second thing here, the idea that each item in the list comes right before, well, each item in the list is in order. And I want to verify that. So let's call a function that I haven't written yet. I'll do it in a minute. Is in order. Well, the simple thing would be to say if not is in order, we're just going to blow up. And otherwise, we're going to return the list as it is. So, not very exciting yet. Another issue here, we skipped the first thing. The output will be a permutation of the input. Well, how about this? The only thing I'm going to do, the only time I change the list, I'm just going to swap two items. And that's pretty much the definition of a permutation. I can swap as many items as I want, and I just never add anything new or completely delete anything or change anything. So let's make this function. Let's say swap. Index 1 is a number, and index 2 is a number. List index 1, comma, list index 2 equals so this is doing the simple swap. It's grabbing the values out of these two indices and then it's putting them in a different order, just swapping them. Simple enough. So, you know what? Maybe we were too harsh here. This is in order. What if we said while so we're going to have a loop. First, we're going to solve this problem, and we will get to that. And then I'm going to say if everything's in order, then that's beautiful. All we have to do is we're done. If everything's in order, we just return the value. And if we're not done, we're going to try again. That's what this loop says. And by the way, now you see why I said it's going to terminate. It's easy enough to make an infinite loop and say, well, you can't prove I'm wrong. Guess we have to actually define this thing here. Function is in order. This is going to return a Boolean, right? Either it is or it isn't. Yes or no. I'm just going to use the simplest version of being in order, just taking this exactly as is. Item in really needs to be every item except for the last item, because otherwise there wouldn't be a next item. So let's say start from the first index, index 0, and then we want to stop the end of the list, so list.length, and then -1, because we actually want to stop one before the end. Oops. And, well, we're going to do that comparison. We're going to say if list I, so if the first item is greater than the second item, the item right after it, well, then we know it's out of order. So at this point, we're going to say false. But if we go through the entire list and we don't find any problems, return true. Looks pretty reasonable. So let's go through this again. Well, we do the work. That's you know, the easy part. And then we double check that it's in order, just because experience makes people paranoid, at least in this field. If everything's good, we return the result. Otherwise, we try again. We just keep trying, and hopefully we're making some progress. Now, one thing bothers me here. I know that these two items are out of order. It seems like, since I've already done the work of comparing them, I might as well swap them to say it wasn't in order, but let's just get a little bit closer, Every little bit counts, right? So let's say swap I and I plus 1. Those were the two we were looking at. And we'll just switch those two and send out a warning that it wasn't right, so we can try again. So what is this secret ingredient anyway? Oh, you know what? I should probably export this. Let's say all right, little instructions there. Ah, well, oops. Kind of nice if the instructions are right. Hey, what happened there? Everything is coming out in the right order. I'm already done, and I never actually... wonder what the secret ingredient was. Let's try a tougher one. Let's say, Yeah, it was not a fluke. It is actually putting stuff in the right order. I think it's fair to say that this is the simplest sorting algorithm I've worked on. But are we sure? So we know the order is right because, well, it passed this is in order test. And we know it's a permutation because the only way we changed things was swapping things. And what about this last question? Will it terminate? Well, that is a little bit trickier, but not by much. So this is an order thing. I was comparing each item to the next item right after it. There's another way to say the exact same thing. You can say each item must be less than every item after it. Completely the same. It's either one. If one is true, then the other's true. If one's false, then the other's false. I use this simple thing because it's fast and it did the minimum amount that I needed. But the other one is interesting, the one where we're comparing each item to every item after it. So let's call this how close, or how many problems. And it's pretty straightforward. Start with this same loop for each of the items except for the last one. You know what, it really doesn't matter. Yeah, the last one will be compared to 0 items. It just a slightly shorter and simpler here, and it doesn't matter. So now let's look at a second index here. So let's say for let j equals, so it's got to be at least I plus 1. Because again, we want to compare this to everything after it, not to itself. And again, we're going to the end of the list. And finally, go to the next thing. All right, so we want to say how many problems. Well, we're going to need a counter. So initially it's 0, and we add 1 every time we find a problem. So we'll say if the item at position I is greater than, so if there's a problem, then we'll say add 1 to our counter. Seems good enough. There we go. And then finally, return the problem count. All right, so now what's going to happen here? Well, let's, and this is only for debugging. This would make things so much slower than they need to be. This is just to help us understand what's going on. So let's say console.log and let's run it. So at the top of the list, it's going to tell us how many things are out of order. And each time we go through the loop, we'll see what happens. And let's take a look. Ah, now that is interesting. There's a bit of a theme here. It started with 25 things that were out of order. So this was fine. 27's before 100 and before 45, but 27 should be after 1. And also 100 should be after 1. And 45 should be after 1. And in fact, our algorithm would go right up to this spot and find that these two are out of order. Oh no, I guess it would find these first, because these two were fine, but these two are out of order. And then it swaps them. Nothing else changes, just those two. And the problem count went down because I fixed that one problem, and it went down by exactly 1 because there was nothing else affected, only these two items swapped. And the next time I went through and found another problem and another. And we know we're going to finish because there's a finite number of problems. Worst case, every item is out of order. But each time we fix exactly 1, and if you just keep taking 1 away from any finite number, you're eventually going to get to 0. And again, 0 problems is exactly the same as, hey, everything is good and we can quit. Now, of course, that leads to some interesting questions. We're fixing exactly 1 problem every time, and there could be a lot of problems. So the question is, if we're only going down by 1 problem at a time, surely there's a better algorithm, a faster algorithm that can do more than 1 thing at a time. And of course there's so many to choose from. I just picked this one because it's the simplest one. Okay, I recorded this a little bit out of order. If you want to see how I started this project, I'll put that part next. And I need to do a little bit more work before I can post this to GitHub, but there will eventually be a link in the description for that. Thank you for your time. Okay, let's create a new project. Secret ingredient. Am I spelling that right? Sort. Vanilla. TypeScript. And I always like my own library. Should really create a template of my own. And let's open this up. Oh, come on. All right. And we got a bunch of extra stuff. I usually do a better job of deleting it, but for now, let's not worry too much. In fact, all I'm going to add here how about and let's go here. Yeah, none of this matters. I'll just leave it.